In this lecture, we are going to look at technologies for on-site black water and grey water management, including the septic tank and the biogas reactor. These technologies are based on anaerobic processes, and I will just explain what that means. The word anaerobic describes biological processes that occur in the absence of oxygen. These processes naturally take place in swamps, marshes, ponds, and other standing water bodies. They can easily be recognized by the formation of gas bubbles, as shown in these beautiful photographs. The gas is formed, for example, at the bottom of a pond, where the anaerobic bacteria decompose carbon-rich organic substances into methane and carbon dioxide, also called biogas. The gas bubbles then rise to the surface. In cold areas, where the lake surfaces freeze in wintertime, it can sometimes be observed that the bubbles get trapped below the ice surface, as shown on the two pictures on the right side. In wastewater engineering, we often talk about anaerobic digestion. The term anaerobic digestion refers to the degradation and stabilization of organic matter by microorganisms without oxygen, leading to production of biogas. Both anaerobic and aerobic processes are used for wastewater treatment. The aerobic ones need aeration systems to provide enough oxygen and are technically a bit more complex. They are therefore not so commonly used at the collection and storage level. We will introduce those technologies later in the lectures about centralized and semi-centralized treatment. So much for an introduction to the general processes. Now we want to look at a few technologies. The septic tank is among the most widespread on-site sanitation technologies. There are two important things you have to know about the septic tank. First, it is a watertight tank, typically made of reinforced concrete, polyethylene or fiberglass, and second, it has an outlet through which the clarified effluent leaves the tank. In practice, people are not always aware of those two aspects. They may even call an open bottom pit a septic tank, which is actually wrong. Black water and grey water enter the tank through an inlet T. Settleable solids fall down to the bottom where they accumulate as sludge. With time, the sludge undergoes some stabilization by anaerobic digestion. It has to be removed every 3 to 5 years. Floatable substances move up to the surface, forming a scum layer. The effluent from the clear water zone in the middle flows out through an outlet T and is then typically infiltrated, for example, in a leach field. 1 or 2 separation walls in the tank can improve the solid-liquid separation process. The good thing about septic tanks is that they are passive and do not require electrical energy to function. This makes this technology quite robust. Construction is relatively costly, but the technology has a long service life and requires little maintenance. The costs for mechanical emptying, however, may be considerable. Little space is required because this technology is typically built underground. On the negative side, it has to be mentioned that the removal of pathogenic organisms, suspended matter, organic substances and nutrients is relatively low. Therefore, the effluent, as well as the sludge, require further treatment and/or appropriate discharge. To ensure optimum performance of the septic tank, it has to be regularly pumped, as shown in the photo. An anaerobic baffled reactor, or ABR, is like an improved version of a large septic tank. Its functioning is very similar, but it is equipped with baffles which form several anaerobic chambers to remove and digest organics and improve the treatment performance. The treatment can be further improved by providing 1 to 3 fixed bed filter units, which help to trap non-settleable suspended particles and provide an increased surface for microbial growth. This technology is called anaerobic filter. An ABR, or an anaerobic filter, can be installed at a small scale for on-site collection and treatment, but also at semi-centralized or centralized treatment level. More detailed explanations of these two technologies will be provided in Module 3.2. In the septic tank, ABR or anaerobic filter, the gases produced in the anaerobic processes are just released into the atmosphere because their quantities are relatively low. A biogas reactor or anaerobic digester, however, is designed to generate as much biogas as possible and to capture and collect it so that it can be used as a renewable energy source for cooking or other purposes. The black water from a toilet can be directly connected to the digester. In order to produce significant amounts of biogas, additional inputs like cow dung or organic solid waste are normally mixed in at the inlet. The substrate flows into the reactor, where it has a retention time of typically 15 to 25 days. The biogas collects in the dome at the top of the reactor and is transported to the point of use through a gas pipe. When new substrate is added to the reactor, or when the gas pressure rises, the digestate flows into the expansion chamber from where it can be removed. On the photos, you can see some examples of different biogas reactor designs. The picture on the upper left shows a fixed dome reactor under construction. This is another fixed dome digester similar to the one previously shown on the drawing. As you can see, the space requirement is quite low because it can be built underground. On the right side, you can see a floating dome reactor where the gas storage can move up and down depending on the gas volume inside, and this one here is a biogas stove. This technology has the clear benefit that no energy is required for operation, but energy is actually produced. A high reduction of organic matter and particles can be achieved. The digestate is almost odorless and still contains all the nutrients, so it can be used as an excellent fertilizer. However, the agricultural application has to be done correctly and carefully, because the digestate may still contain some pathogens. This technology has many benefits, but its success depends on correct implementation by experts, proper operation, and regular maintenance. We have seen that there are several anaerobic technologies that are robust and easy to operate for on-site treatment of black water and grey water. I want you to remember two things from this module. First, septic tanks can be a good solution, but it is important that the effluent is properly disposed of and that the sludge is regularly removed. The second thing that I want you to remember is that the biogas reactor can be an attractive technology, but the economic benefits do not mean that it is always automatically successful. Whether or not the initial investment costs can be recovered will depend on the correct design and implementation and a motivated operator.